So far, we talked about agentic AI. We talked about how people do it, how people like it. But is everything hunky dory? Is in the sense that is everything perfect? Any thoughts on that?
Nothing
One
is
thing,
perfect.
Manpreet.
Sorry.
Manpreet, one quick thing that while we are building AI agents for different purposes, right? Even for the client deliverables, somebody asked, how do you ensure that the AI agent does what it is supposed to do? And
Hmm.
like there are no hallucinations, no biases, and something like that. How do we ensure that? What
Yeah,
kind of
that's a
parameters or metrics?
that's a good point, Prabhakar. And we'll be touching base on that itself in next 5 to 10 minutes. We'll not go deeper,
Sure.
but we'll
Yeah.
touch base on that. That's a fabulous point. Thank you, Prabhakar.
Thank you.
Can we say ask LLM itself do not hallucinate as an instruction?
Yes, that's what LLM as a judge is. Thank you, Ram. So we'll talk about that. One other thing which I want to point out from the statistics perspective, high rate of agentic AI project failures. So Gartner predicts that over 40% of the agentic AI projects will be cancelled by 2027 due to escalating costs, unclear business value, or inadequate risk controls. There are Standard and Poor says that 40% of the companies abandoned AI initiatives in 2025. Similarly, there's a new term which has come like agent washing. Only 130 of the thousands of vendors offer genuine AI capabilities. All others are pushing and saying that, okay, their deterministic code or their application is agentic AI, but nothing in that might be agentic AI or otherwise. I've seen people, rather, it's a little bit funny. Somebody reached out to me, one of my customers, and said that, hey, can you expose API interface from my server, but make sure that that API is exposed as AI agent. So I was more like, is this a deterministic API which does a fixed logic, or is it probabilistic API will use LLM to actually reason out the flow and do act based on that? No, he says it's deterministic, but I want to expose it as AI agent so that I get a venture capitalist funding. So that's a little bit funny, but it's true. There is agent washing happening a lot. And that's what I would say, that AI agents are probabilistic because of the AI models being used. And it should not be used where we know that the logic is deterministic. For example, in my bug fixing issue, when I did a git clone or creating that GitHub pull request creation, I did not call an agent. I created it myself using the API because that's very deterministic. We have to do it that way only. There is an API available for that. We'll do it that way only. So that's where I somehow feel that a lot of agent washing is happening, where leaders mistakenly use agent where deterministic precision is desired. So that's what I think, that is the foremost reason of failures which we are seeing in the reports. How many of you have seen that blockchain era where even people were implementing a very simple database as a blockchain? So that similar thing is happening now where people say that, okay, hey, let's do agentic AI for something very deterministic and let's make it happen. But it should be used where it should be used. It should not be used at other places. Another issues which I have seen is that lack of observability. For example, I have seen quite a few people rolling out agents where they don't even have the tracing. We saw that tracing in picture in the bug fixing agent which we saw. Now, also cost tracking comes as part of that. You should be able to see that, okay, my agentic application, each run is costing this thing. Do I need to optimize? It's costing me a bomb. Do I need to optimize? And even you'll be able to debug that application. So that is second issue which I have seen with most of the agentic AI projects failing because of this. Another one is lack of evaluation, which Prabhakar and Ram were also mentioning earlier. There has to be a way by which we could evaluate the output of an agent and either repeat the agent execution based on that, which is critic pattern, uh, which I would have shown in that deep research. But having said that, critic pattern is more like when the agent is getting executed, just after the execution, there is a critic agent which comes into the picture, evaluates the output. If it's good, if it's not good, it circles back. Very similar to what we saw in the bug fixing agent. The validator agent was an implementation of a critic pattern. LLM as a judge is the one which is after the execution has happened, you could put a score to the execution and say, another LLM is evaluating my agent's output, giving it a score, hallucination, giving it a score on bias, giving it a score on, let's say, profanity or all other aspects. Third thing, which I feel is so important, security issues. There are attacks like prompt injections, which are happening. But before that, let me show a very important slide. Web security versus agent security. Now, this is a very good way of articulating the security issue in agent. Now, in general, if you see on the left side, web security is more like if my web application is a fortress, I'm trying to stop intruders from trying to break into my web application. But on the other side, when we talk about agent security, I have opened the door of my fortress and I have pushed out a digital employee, which is the agent, and it has the keys to the fortress. Now, if somebody is able to manipulate my agent and get those keys and get into the fortress, I better save myself. So the complexity changes such a thing. So in a way, we have seen in the past where people talk to the agent, did prompt injection attacks, and got the whole database deleted for a particular, you could say, application. So in a way, because the agent is more like a digital employee having access to that database, somehow the user talked to the agent in such a way that got the whole database deleted. We have seen instances, I don't remember the car manufacturer name, but there was a car dealership. A customer talked to the car dealership's chatbot and got a car for just $1 by just modifying and tweaking the input to the agent and getting it done. So web security versus agent security. If web security is of X complexity, agent security is at least 10X. So any thoughts on this before I jump to the next slide? Okay.
Manpreet, the agent security is particular. I mean, the prompt injection. Like, I mean, who is the bad guy? Is there an external user or the LLM itself actually acting as a bad guy? I mean, like,
Yeah, good point. Both cases are there, Ram. So generally, I've seen more number of cases to be the external user, but there are LLMs which hallucinate,
right.
right? There are LLMs which can expose personal information based on the data which it has been trained on. So there are issues with LLM as well as the input. So good point. There are quite a few more issues which are making agents fail in production. One is the automatic testing is quite tough. So imagine a situation that, okay, you have put a web service, which is very deterministic, doesn't use any agent. You want to test it out, you can say, these are the test inputs. And it's very deterministic. You could say, okay, these are the inputs, which goes to the agent. We can test it out. But with agentic, it's very tough because generally the text is passed to the input or image is passed to the input to an AI agent. And that so many different ways of input could be given to a testing agent, given to an agent. And this is, by the way, my area of research these days. If you know someone or if you have done production deployment of AI agents, do let me know. I'll try to get 20 minutes of your time to publish my research report. Now, somebody said costs. LLM adds a lot to the costs. Each LLM call adds up. And that is something which, coming back to the point where LLM or agent should be used only when it needs to be used, so that the cost is justifiable. And certainly LLM introduces a lot of latency. Trying to put LLM for every situation is not right. just a single call costs seconds, 3 to 4 seconds, 2 to 3 seconds. Even if you have faster LLMs, you have 1 to 2 seconds. But that loop in itself, trying to make call to the tools till the time the goal is achieved, that loop itself could land up in, if that loop is 20 times and you're calling LLM, each call costs 2 seconds, we're talking about 20 seconds latency. Another reason which I've seen for the failures is not using right protocols like MCP, A2A, and more. Also not using the right agentic patterns. So we saw router pattern in action for the Amazon chatbot. We saw the sequential pattern in action in the bug fixing. There's another pattern for Swarm, which is more like agents talk to each other and delegate to each other like a self running team. So there are quite a few agentic patterns. Picking up the right agentic pattern is something which is very important.